Let's have a look at some more very basic binomial expansions. We're this time going to make things slightly different from the last video, slightly more difficult, but they're still pretty basic expansions. So let's go through this one. We've got 1 plus x to the 5. Now obviously if I wanted to, you realise that 1 plus x is the same as x plus 1, so I could actually flip the two terms around inside the bracket and say it's exactly the same as the expansion that we've already done in the very first video, the very first expansion that I did with you in these videos. However, I'm just going to expand it as it stands there, and I'll show you do get exactly the same expansion coming out, but it'll be back to front compared to the first video expansion that we did for x plus 1 to the power 5. So here we go, very quickly. You say first term 1 to that power 5 plus, next you say 5, choose 1, and then we have this first term 1 to the power 4 now, goes down to a power 4, multiplied by the second term is plus x, and you raise it to a power 1, like so. Plus, next, 5 choose 2 comes next, then we have 1, power 4 becomes a power 3, and then we have a plus x that increases to power 2. Next, we have 5 choose 3, the plus 1 power 3 becomes plus 1 power 2. And then the x squared rises now to a positive x to a power 3. I'll carry on underneath here, plus 5 choose 4, then we have 1 to the power 1, and the plus x cubed becomes a plus x to the power 4. Plus, and then finally we have a plus x to the power 5. If you want to just write plus x to the 5, you can do so. Okay, let's sort this out. 1 to the 5 is just 1. Plus 5 choose 1 is 5, times 1, times, that's just x, you get 5x. Plus 5 choose 2, well we've done it once already in the previous video, 5 by 4 over 2 by 1 works out to be 10. So you get 10 times 1 times x squared, so you get 10x squared. Plus 5 choose 3, symmetry, same as 5 choose 2, that's 10, 5 by 4 over 2 by 1, so that's 10 by 1 by x cubed. That's just 10x cubed. Plus 5 choose 4, same as 5 choose 1, that's 5 by 1 by x to the 4. That's 5x to the 4. And then this simplifies to simply become plus x to the 5. And that's it. You can see, because these are still 1 and 1x there, we still have a symmetry of coefficients. A 1 with a 1, a 5 with a 5, a 10 with a 10. Because they rely solely on the choose values, and the choose values are always symmetrical. Let's do a slightly different one now. But the next one I'm going to go back to x coming first, but I'm going to make the second term a minus 1. And let's see what happens when we have something like x minus 1 to the power 5. Let's expand that. First term, x to the power 5, plus 5 choose 1, then we have x going down to a power 4, and then the second term is minus 1 to the power 1, plus 5 choose 2, x goes down to a power 3, and then we have minus 1 rising to a power 2, plus 5 choose 3, x falls to power 2, and minus 1 rises to power 3, plus 5 choose 4, x falls to a power 1, minus 1 rises to power 4. Plus, x is vanished now, and you just end up with minus 1 to the power 5. Tidy up. X to the 5 comes first. 5 choose 1 is 5. Now be careful this time. 5 times x to the 4, minus 1 to the power 1 is minus 1. So you're going to get 5 times x to the 4 times minus 1. That's minus 5x to the 4. So you're getting a minus there. Next, 5 choose 2, if you remember it was 10, 5 by 4 over 2 by 1, that's 20 over 2, 10. 10 by x cubed, and then you're going to get minus 1 and you've got to square it. Well, minus 1 squared is plus 1, so you're going to get 10 times x cubed times 1. So that is positive 10x cubed, so it's gone positive again. And this is what you'll find for this particular type, where you've got a minus in the middle. The sign alternates from plus to a minus as you go through the expansion. Next one, 5 choose 3, same as 5 choose 2 is 10 times x squared, so it's 10x squared, times minus 1 cubed. Well, minus 1 cubed is minus 1, So you're going to get 10x squared multiplied by minus 1, that's minus 10x squared. Next, 5 choose 4 is 5, times x to the 1, times minus 1 to the 4. Well, minus 1 to the power 4 is positive 1. Positive 1 times x to the 1, which is x, times, and then this is 5. So you're just going to get positive 5x. And then finally you've got minus 1 to the power 5. Well, minus to the power 5 is going to be a minus, and then 1 to the 5 is 1. And there's the expansion. Once again you get symmetry of coefficients, 5, 5, 10, 10. But notice you have the alternating signs taking place, which is important. I'll do one more on this short video of another slightly more awkward but still basic example. Okay, the next one I'm going to try doing then is this one. I'm going to do 2x plus 1 to the power 5 still. I'll stick with 5 for the moment. In future videos I'll change them to different powers and so on. Okay, I've got to expand that. So you take the first term. Now, you've got to take the whole thing. It's 2x raised to the power 5. So it's very important that you put the 2x inside a bracket and raise the whole thing to a power 5. So it's not 2x to the 5. It's not this. It's not 2x to the 5. That's wrong. It's 2x all to the power 5. Plus, then you have 5 choose 1. It's going to be 2x in a bracket to a power 4 this time. And then the plus 1 becomes power 1. Plus 5 choose 2, then it becomes 2x, falls to a 3, make sure it's in a bracket, and then you have plus 1 raises to power 2. Plus, then you have 5 choose 3, 2x now falls to a power 2, and the plus 1 rises to power 3. Plus 5 choose 4, 2x falls to a power 1, plus 1 to a power 4. And then finally plus 1 to a power 5. And the 2x completely disappears and there's no more choose values. Let's tidy this up. Now just be careful with this because the 2, the involvement of this 2 inside this bracket. If you take the 2x to the power 5, it's 2x times 2x times 2x times 2x times 2x. I think I got that right. Which gives you actually 32x to the power 5. So you have to say 2 to the 5, 32, x to the 5, x to the 5. Plus, now at this stage in the past when I was doing this in class, I probably used a colour. So if I get a colour, see if I've got a colour. I don't know how well this will show up, but what I'd normally do is put a line through that there and work out that 2x to the 4, well 2 to the 4 is 16, x to the 4 we've got then, and 5 choose 1 is 5. So what you've got is 5 times 16x to the 4, and obviously that is times by 1. So that's what we've got there. We've got 5 by 16 by 1, well 5 16s are 80, times x to the 4, times 1 obviously stays the same. Plus, then we've got 5 choose 2. Well, okay, let's get my colour out. 5 choose 2 is 5 by 4 over 2 by 1, that's 10. Multiplied by 2x all cubed, well 2 cubed is 8, x cubed then. And of course plus 1 squared, you times it by another 1. So I've got 10 times 8 times the 1 on the end is 80. And this is 80x cubed. Plus, this term now, this one here, 5 choose 3 is the same as 5 choose 2, which is 10. I've just done that 10 up there. And then 2x squared, you're going to get 4x squared. Times the plus 1 all cubed is plus 1. So you're going to get 10 times 4 is 40, times 1, still 40, x squareds. Plus, next one, 5 choose 4 is the same as 5 choose 1, which is 5, times 2x to the 1 is just 2x, times plus 1 to the 4 is just plus 1. So you get 5 times 2x times 1, that's just 10x. And then the last one, plus 1 to the 5 is just plus 1. And that's the expansion, 2x plus 1 to the 5. Now at all times throughout this expansion, The choose values are symmetrical at any stage. It's a symmetrical case for choose values. But because of the involvement in this 2 in these brackets, when you actually expand it out, you do not get a symmetry of coefficients for the final expansion. You get 32 corresponding to a 1. They're not symmetrical. You get an 80 corresponding to 10, and the 2 central ones are 80 and 40. They are not symmetrical, and it's because of the 2 involved in the first term there. So that is a typical example of a slightly more awkward one involving a 2x at the front. That's the end of this video. In the next video I'll take you through 2 or 3 more examples similar to that, and I'll gradually make them a bit more difficult.